For someone who's familiar with filtration methods in general for chromatography sample prep, how do syringe filters compare?
How do they compare? You got to really look at the basics. So there's a number of factors when you're looking at syringe filters. The membrane type is the actual filter component that's in the device. And so typically in chromatography, you're using nylon, PTFE, PVDF, or PES. And for nylon, that would be suitable for aqueous solution and organic solvents, very commonly used in general HPLC. In PTFE membranes, PTFE is resistant to aggressive solvents, acids, and bases, and it's really ideal for organic solvents. PVDF is low protein binding and suitable for biological samples. And then PES, polyether sulfone, that's low protein binding, high flow rate, and generally good for aqueous solutions. So once you've chosen your chemical compatibility and the best choice of membrane type, then you have to look at the porosity, what the actual pore size of the membrane is. And this is based on the particle that you're looking to capture. The two basics are 0.45 and 0.22 micron. Generally, 0.45 is for general HPLC, and zero point 0.2 would be used in UHPLC, which is ultra high pressure liquid chromatography. LabExact actually has a line of membranes that are available in syringe filters that we call TruPor. We partnered with the leading supplier of high-tech materials, porous materials, by the name of Hollingsworth and Vos. And this was a long-standing, very well-funded development project where they developed a new category of membrane using nanotechnology. And what we do is we are actually able to control the pore structure with the same precision as a cast film membrane. We're able to raise the loading capacity of the membrane, but we increase the flow rate at the same time. And I hope we'll talk a little bit more about flow rates and back pressure when we get into it, but it's an important factor. And so, in working with the same polymer groups, we are able to introduce this new category of product, which is just a superior membrane. And then the diameter of the device itself. So, this is a relationship of the device size, which translates to the surface area of the membrane. And then that surface area contributes to the device's ability to load or sample the volume that you're working with. And so if you're working with a very small sample, you would generally want to use a small diameter membrane, and a larger sample size, of course, larger. And it's a process of finding the right category of product. So you really have some variables here, and that's what makes our product line so big. We've got over 300 SKUs to choose from, but the basics of it are membrane type, diameter, and pore structure.